Understand the concept of salt hydrolysis. When an ionic salt dissolves in water, it dissociates completely into its component cations and anions. These ions can interact with water molecules in a reaction called hydrolysis, which can produce either hydronium ions, H3O to the power plus, or hydroxide ions, OH to the power negative, altering the pH of the solution. Classify the behavior of cations in water. Cations of strong bases, such as alkali metals like Li to the power plus, Na to the power plus, and K to the power plus, and alkaline earth metals like Ca to the power 2 plus, do not undergo hydrolysis and have no effect on pH. They are neutral. Highly charged, small transition or post-transition metal cations, like Al to the power 3 plus, undergo acidic hydrolysis because they attract water molecules strongly, causing them to release H to the power plus ions into solution. Al, H2O, 6, to the power 3 plus plus H2O is in equilibrium with Al, H2O, 5, OH. To the power 2 plus plus H3O to the power plus. Classify the behavior of anions in water. Anions derived from strong acids, such as number 3 to the power negative and Cl to the power negative, do not undergo hydrolysis and have no effect on pH. They are neutral. Anions derived from weak acids, such as SO4 to the power 2 and CO3 to the power 2, act as weak bases. They undergo basic hydrolysis by accepting protons from water molecules to produce hydroxide ions. An ion to the power negative plus H2O is in equilibrium with conjugate acid plus OH to the power negative. Compare the base strength of the hydrolyzing anions. The strength of a conjugate base is inversely related to the strength of its parent acid. The conjugate acid of the sulfate ion, SO4 to the power 2, is hydrogen sulfate, HSO4 to the power negative, which is a relatively strong, weak acid, Ka approximately 1.2 times 10 to the power minus 2. This makes SO4 to the power 2 an extremely weak base. The conjugate acid of the carbonate ion, CO3 to the power 2, is hydrogen carbonate, HCO3 to the power negative, which is an exceptionally weak acid, Ka approximately 4.7 times 10 to the power minus 11. Because its parent acid is so weak, CO3 to the power 2 is a much stronger conjugate base. Identify the most basic solution. Since potassium carbonate, K2CO3, consists of neutral K to the power plus ions and highly basic CO3 to the power 2 ions, it undergoes significant basic hydrolysis. CO3 to the power 2 plus H2O is in equilibrium with HCO3 to the power negative plus OH to the power negative. This produces the highest concentration of OH to the power negative ions, making the 0.10 molar solution of K2CO3 the most basic among the choices, which confirms option E. The correct answer is option E, K2CO3.